Hello. Hello, everyone. Welcome. Good afternoon, good evening, wherever you may be. Thank you for joining us today. And welcome to today's streamingmedia.com webinar sponsored by Ant Media, CDN77, and Verimatrix. I'm Steve Nathans Kelly. I'm the VP and Editor-in-Chief of Streaming Media, and I will be your host and moderator today. Today's webinar, if you didn't know, is entitled Tech Talk, Delivering Live Streams at Scale. So before we get started, we got a few quick housekeeping notes. We will have a live Q&A session at the end of each presentation. We're going to do 3 presentations in sequence. And at the end of each one, you'll be able to ask your question of the presenter who's just spoken. And you can actually put your questions anytime in the Q&A panel. Please chat amongst yourselves in the chat, and we encourage you to keep chatting there. But put the questions in the Q&A tab, just so if the chat is lively and active, we'll be able to see them and get the questions to the panelists. I will actually read the questions to the speakers at the end of each segment. And if we don't get to your question while we're live, we'll get you an answer once the event is over. So the webinar will be archived within 24 hours after we're done for on-demand viewing. And just for participating in the webinar today, you'll be entered to win an Amazon gift card. And we'll actually announce the winner at the end of the hour, and you must be present to win. So I'm going to introduce today's speakers. First, we have Amit Memurkaya. I hope I'm saying that right, co-founder and CEO of Ant Media. Welcome, Amit. And we're going to have Uri Kakaba, head of client implementations at CDN77, and Sebastian Braun, head of Streamkeeper and product management at Verimatrix. And we're actually going to start with Amit. So let's see, we're actually just going to do a little Q&A here, but first of all, Amit, if you've got some kind of introductory remarks, just tell us a little bit about yourself and about Ant Media. That would be great.
Yeah, definitely. So firstly, guys, thank you for having us. It's a pleasure to be here and talk about live streaming at scale. So thank you again for this opportunity. So as you say, my name is Ahmet Oğuz Memurkaya. So I'm the co-founder and the CEO of Ant Media. So the Ant Media is a company that creates the Ant Media server. And the Ant Media server is a generic streaming engine. It provides different features, different protocols, such as WebRTC, HLS, or TMP. And it creates a real-time streaming solution at scale. And the company has customers from more than 130 countries. And it is a generic streaming engine, and it can fit to any video verticals. So I think it is a quick introduction for the company and what we do.
Okay, great. And so obviously our topic today is live streaming at scale, and it's a broad topic. There's lots of different kinds of large scale streams that people do. But so what are some of the specific and interesting use cases that you're seeing that you can talk about here?
Yeah, so as you mentioned, the streaming cases is, in some cases, it is very generic. So for instance, media and entertainment, and live video monitoring, surveillance, video conferencing, webinars, gaming, esports. There are a good number of use cases that Ant Media server can have a critical role to make these use cases be successful. And there are also some interesting use cases as well. You know that video surveillance is just a common stuff. Auction bidding are also telehealth is very well known video verticals that real-time streaming can be a critical role. On the other hand, some interesting use case for me is something like autonomous delivery robots. Or some kind of skyscraper window cleaner robots. So in these use cases, I think that this is very interesting. And there are some kind of, let me tell the structure there. For instance, for the delivery robots, they put a camera in the robots, and they just stream the data to the edge point, for instance, in AWS wavelength. And they run their own algorithm to detect if there's some kind of problem in the road, and there is a pilot that is just controlling the robot, and they use the Ant Media server just in the middle to transmit the live stream in very ultra low latency way and control everything. And also the Ant Media server provides running custom AI or object detection, image processing algorithms behind in the server side. So I think these are the common use cases, and this is the last thing is just an interesting use case.
Yeah, definitely interesting stuff. And you know, one of the things that, you know, we inevitably talk about when we talk about streaming at scale is challenges, because generally the bigger the screen, the bigger the stream, the bigger the challenges can be. So, you know, which challenges, you know, there's so many different kinds of challenges people face when doing large scale streams. You know, which challenges are you resolving at Ant Media?
Yeah, so when we are talking about scaling, I think we just need to mention that the horizontal scaling. So, for instance, for the robot case, there may be number of robots that push the stream to the Ant Media server, and each robot probably will have just a one pilot. So it is something like that. On the other hand, in some other cases, there will be just one broadcaster, and there are tens of thousands of people or hundreds of thousands of people just watching them. There will be too many viewers in these scenarios. So what the Ant Media server resolves is that it just resolves the scalability problem in real-time streaming. So my video can be transmitted to tens of thousands of people, hundreds of thousands of people with half a second latency. So this is the main challenge that Ant Media server resolves in the live streaming. On the other hand, the customer cases are different. So the customer has their own challenges. And because Ant Media server provides a very generic streaming engine, by using its APIs and its abilities, we resolve their challenges as well. So just let me give some samples for that. For instance, I think 2 days ago or something, I just had a meeting with one of the users. They are using one of the cloud provider streaming service. They're okay with that, but their problem is that they say that it takes about 20 minutes to start these infrastructure. And they just migrate to Ant Media server because everything will be ready under 1 minute or something like that. So this is the challenge that we are resolving for this customer. And in another customer, so they have a very big pipeline. They are making green screen stuff. They are transcoding in different parts. They are having GPU instances in different pipelines. So when they use the Ant Media server, they can do everything in one instance in having a GPU. They can make the transcoding, they can make the green screen filtering stuff, and then everything is ready. So for this customer, I think the simplicity is the challenge that we resolve. Maybe the last sample that I can give from one of the customer scenario, it's a giant customer, and they are using a very well-known communication platform as a service. So yeah, it is the correct stuff. So their cost is very huge, and it's really hurting for them. They are migrating to Ant Media server to just decrease their costs because they scale too much, and their costs will hurt them further. So I mean, maybe in short, I can say that the challenge we resolve is to create simple solutions for the complex problems. So I think this is the answer for that.
Yeah, I think that's a good description. You know, it's definitely complex problems. And you know, you touched on a little bit on kind of 10,000, 100,000. Yeah. What really is a typical scale for a streaming event, you know, that you would do?
So yeah, typical for especially in the real-time streaming, the typical scale starts from hundreds to tens of thousands. It depends on the use cases. So for instance, in a robots case scenario, it does not scale too much. But for a, let's say, video chat application, I'm appearing in one of the video application. There are tens of thousands of people are just watching me. In some scenarios, it just increases to more than 100,000 users or something like that. So, and also, you know that the real-time streaming, there is some kind of, how can I say, prejudice for the real-time streaming that it can be scaled to hundreds of thousands of people. So last year, we just had an experiment to scale to 150K viewers in our test. And we just create a white paper for that one. And in this year, our target is to have a 500,000 to show that, yeah, the real-time streaming can be doable to 500,000 people. And we provide a quality of service in the video transfer, audio transfer, and everything will be smooth. So yeah, I think our goal is to make the real-time streaming to go to the mainstream.
Great goal. So, and also just kind of looking forward and looking ahead to the future and goals and so forth. I don't know how much you can reveal here in this webinar, but do you have some interesting challenges or kind of innovative, interesting things on your roadmap that you plan to deliver, you can tell our audience about today?
Yeah, we have some things challenging. So generally, as mentioned before, we just create simple solutions for complex problems. So for instance, okay, let me tell in this way. So we have traditional things on our roadmap, such as new encoders. We will support AB1. We will support SVC. We will support DRM. Maybe we will work with Varimatrix or something. But for the interesting stuff, what the cloud providers does not resolve this problem is the aggressive scaling. So for the customers from our end, they are saying that they would like to pay less for maintaining the system. And when there is a high load in the system, they just want to make everything ready in less than 1 minute or less than in 2 minutes. But by using the traditional cloud provider solutions, you cannot manage it in a very easy way. So what we are going to do to provide an aggressive scaling. So let's say that if there is a incoming request that is expect 10x more than the expected user, then the server backend structure will handle that in less than 2 minutes by creating some custom stuff. So even it seems that it is not a very critical stuff, but it has a very common case that our customer asks. And another user experience that we plan to provide is, when you use a communication platform as a service, they have the infrastructure ready. But in the end media server, we don't provide them as a service. We don't provide the cloud as a service. Okay. We just provide the product and make the users install the cloud to create their media streaming service, cloud service in a very easy way. What is missing is that the coverage in all over the world. So in the communication platform as a service, they will have the infrastructure and setup ready in everywhere. With our new roadmap item, we will provide this experience in any cloud provider. First, probably we will start with AWS, and they will pay very less to keep this infrastructure ready, because we just spin up the instances according to the incoming demand. I think this is the interesting and aggressive features that provides high availability and reliability for the users. Yeah.
Definitely, definitely. And there's a lot of stakeholders in the scenarios that you're talking about here. And so how do you build kind of a win-win experience with your partners and your community developers and your users?
Yeah, it is a very good question. I think because the Ant Media Server is a generic streaming engine, we are receiving lots of questions that, can you create an auction platform? Or can you create a webinar platform or video conferencing solution? On the other hand, we don't have the resources, or we don't want to make everything in our hand. And some of our customers have already implemented these solutions and they are already selling it. So what we are doing is that we are just creating a kind of marketplace to let our users sell their own solutions, because I know a good number of users that have an e-learning platform. They are selling them. And we are just saying that when we receive a request, hey guys, do you have an e-learning platform? We don't want to say no. We just say that, yeah, there is a solution and it is available in there. So I think it is the win-win part. And moreover, for the marketplace, you see that we cannot make all the implementations. We just create this marketplace, create hackathons to let the developers create some kind of plugins and applications. For instance, there is no plugin for speech-to-text captioning. There's no plugin for that. And users are just asking this plugin, this ability, and the architecture are there, the plugin architecture are there, and we will just create hackathons to let the developers create these solutions, implement these solutions, and sell them. The marketplace is already available in the Ant Media Server. It is just getting started, and some developers already selling their applications there, and there are a number of transactions happening there as well. So it is getting started, and then I think it will attract more users. And maybe I can also say that we are creating an ecosystem, developers, users, community, and our goal to be the WordPress of the streaming world. So we will just have the product, we don't give a service, and we will just let the developers create the applications, create the plugins, and use this for their video verticals.
Great. I think that's an ambitious goal, to be the WordPress of
yeah. So we are just running after our dreams. Yeah.
So yeah, just one last question from me, just kind of to sum things up. So if you take a look at the whole picture, and what would you say is the general value that you create as a company?
So for the general value, I think at the first glance, we just improving the communication between the people. So maybe, in other words, we are just removing the distance between the people and the devices, so that there will be just real-time communication between everything. So life will be easy. This is the first glance, but in the deeper purpose, just let me tell a very quick story for that one. So I was a software engineer in one of the tech company before I started this business. And I was thinking that creating a company or building a company is just a crazy thing for a good amount of time. So I had this idea. And because you know that when you build a company, there are also, in a startup world, it is very challenging. There are too many problems, challenges, so that it is hard. But something that just pushed me out of my comfort zone, because I just think that working for a company, getting some kind of titles, and after retiring is not very meaningful for me, at least for me. So today, in every day, generally, I add more meaning to my life. So I'm just showing that I'm just another simple that no matter who you are, no matter where you are, if you act proactively, work hard and smart, you can make your life and your environment be a better place. So I just would like think that this idea or this behavior should may inspire some people around the world. Yeah, if I take some actions, if I'm bold, so I can make things go better. So something like that. So and my deeper purpose is this one. So this is just making me live all the time. And in order to create anyone in the audience that are willing to be part of this journey for us, I think it will be great. And we can just send coffees, Starbucks gift cards to every attendee to just have a discussion about how we can collaborate together to just create something inspiring for the people in this perspective. And you know that the friends buy friends coffee. So this is just the slogan in the Starbucks gift card. So we just would like to be friends for everyone, to spread the word, to inspire. And lastly, before finishing, I have something very interesting for future roadmap. I just forgot to mention that. If it is possible, I also would like to show it. May I share my screen?
Yeah, just real quickly, because we're a little bit tight on time.
Yeah, it just takes 10 seconds or maybe something like that. So let me share my screen. So yeah, do you see my screen?
Yeah, see it.
So as I mentioned, we just make everything very simple. So in scaling the business, in scaling the number of streamers, we just create a CloudFormation template generator. If you enter your number of viewers and number of publishers, it will create just a CloudFormation template, and it means that you can install your media server service running tens of thousands of people in a couple of minutes. So, and we have this CloudFormation video here. It just shows you how to do that. The most interesting thing is this one. So guys, just take a look at this video. So it is just this yoga video. And you know, there's just a line here. There's just a green button here. So when I click this green button, it just changes the video, and I can watch the video in, I can watch that scene in any position. So I'm just coming back, rotating, go left, rotating, going this way. By the way, this is me. I'm just looking at how it is captured. I'm just returning. So this video just freezes one moment in the video, and you can just walk around in the video. So we call it spaceport. And this is the very first version. And in the next version, you will walk through in the video as it just plays. So, and we call it, and you know that it's calling volumetric video streaming. So this is very exciting stuff for me. So I just would like to share, and I think thank you for this one, and I don't want to take more time. Okay.
Okay, that's great. Yeah, thank you. Thanks, Ahmet. And so we've got to get on to the next presentation here. But Ahmet, if you could actually try to, there's a couple of very specific questions in the Q&A, and it's kind of set up right now that you can't answer them by typing, but if you could just answer them in the chat, that would be great. Just,
sure.
But we got to keep going to the next one. So Uri, if you could come on screen here. Thank you, Ahmet. So Uri.
Oh, yeah. I should back if everything was correctly.
Okay, great. So now our next presentation, we have Uri from CDN 77. And you're going to actually do a PowerPoint presentation, right?
Oh yeah. Let me share the screen in a meanwhile. Set it up. Yeah, this should be it. Just 1 minute because it's asked me for the permissions.
Bear with us here.
Yeah. Security parts. Yeah, I should get it now. Oh, it told me I need to quit and reopen the Zoom. Oh, damn.
Do you want to circle back? Do you want to have Sebastian go next?
I can see it now, so it should start working now. It's all good. Yeah, thanks.
Stop my video, let you talk.
All
right.
Yeah. So so good day to everyone. I'm Jurek Kachoba, and I'm the lead client of client information team at CDN77. Today, I would like to touch upon or talk about the challenges we face as CDN's vendor when it comes down to cutting down the stream latency, while also maintaining the best possible performance for our global delivery. It's quite a technical subject, but we only have some 10 to 20 minutes, so I will talk most about the adjustments and optimizations that we do to accelerate the data flow and transfer the video across across the video processing and the CDN delivery stack itself. So to begin, just to mention, I will stick strictly to HTTP. So when I talk about low latency, I really mean to end-to-end latency, or as we like to call it, the glass-to-glass latency, if you will, around 5 seconds. For anything below that, at least based on my and our personal experience, HTTP is not the most suitable protocol. Of course, we try to go much lower than 5 seconds, let's say below 4 seconds. But when we get to that area, we start to see and get what we call diminishing results. I wouldn't say it's the problem of the protocol itself. In sort of a perfect lab conditions, you could achieve sub-second latency even with ATTP. But when you need to scale it and transfer it across longer distances, 4 seconds end-to-end is probably the best you can get. Obviously, there are protocols offering even sub-second latency, such as WebRTC. Yet I believe HTTP still has its relevance, and it's used predominantly in any use case for its relatively easy scalability, playability, and stability, and of course. And I think stability is the sort of a key phrase or keyword here, because in a way, we can think of latency as a sort of a byproduct that helps keep the stream stable. So to explain the source and encoder a bit. So what you see here, this is a pretty standard live streaming workflow that I'm sure you've seen many times before. Each and every device between the camera and the player adds a bit to the over latency. In transcoding or during creating sort of adaptive qualities, to create the frame at any given time, you need to have some frames from the past and ideally from the future. So inevitably, there will be some delay, of course. Then of course you have packaging and storage, often combined, probably the biggest source of latency. It's where the continuous stream, whether it is RTMP or SRT, is turned into HTTP video segments to be ready to be delivered. And simply put, if you want to create a full 5-second video segment, you will need to wait at least 5 seconds after the 5 seconds event even happens in real life. When you have the entire CDN infrastructure as we have, last mile network transfer and the video player on the website or the app itself, is all of which tends to add a bit of buffer to ensure smooth and playback and experience. To put it very simply, if you do not care much about this latency, you can allow each unit to create sufficient buffers all the way from the transcoder to the player. And when you do that, the data transfer becomes less sensitive to network condition, cache ratio, etc. But the fun begins when you decide to cut down the latency, in which case we'll need to secure much faster and more dynamic data transfer between each devices and each of these layers. So how we do it? How we do optimize the live streaming step? It would break down into 3 interconnected fields. First would be software optimization, caching and edge infrastructure, which is, someone would say is the CDN part of it, and the network infrastructure. So software optimization. By the way, this is not some Shutterstock picture. This is actually a real picture of one of our developers. We tend to use it quite a lot now. He wants to get some legacy rights for it, so we will not be able to use it in the future, but we love it still. So in terms of software optimization, there's still a large pool of features, but essentially it all boils down to the ability to fine-tune the encoder and really quickly produce each chunk, package it, store it, and store it to be available to start with the so-called CDN delivery. Basically, it boils down to the ability to transfer the data before individual segments are fully created and start caching it on the edges, even before they are requested by the client. So to fully understand this, let's have a look at how the video segmentation works and how we can optimize it there. You can think of CMAP as a continuous stream that's broken down into small video segments. They're actually kind of like a small MP4 files, usually between 2 to 10 seconds, depending on what you like to achieve. These video segments can be requested through both HLS, both HLS and MPEG manifest. However, what I'm talking about today is primarily related to MPEG. In the past, latency was mainly controlled by adjusting the segment duration and the buffer size. Nowadays, most solutions rely on the ability to transfer data between individual layers, even before the entire video segment is created. Effectively, we split the video chunk segments into smaller units called HTTP video chunks. You can think of the HTTP chunk as the smallest playable and mappable video unit that may be as small as 100 milliseconds long. Why don't we just shorten the video segment from 5 to 2 seconds, you may ask, to 100 milliseconds? Because from the HTTP perspective, requests are still made to be video segments. So it's always at least a single request per video segment. It's actually at least 2 because the video and audio are separate, but the gist is that the requests are made per video segment. So shortening the duration of the video segment results in linearly more HTTP requests, which results in an increase of CPU usage, etc. Instead of this, we work on the HTTP chunk level and serve requests partially and continuously, even before the entire video segment is created. This process is what we call an HTTP chunk transfer. To start this, we need to teach the encoder to serve incomplete files. If receiving a request for, let's say, 5 or 5 second video segment that has not been fully created yet, instead of answering with the basic 4 or 4 files missing answer, or waiting until the whole file unit is completed, we should serve any video chunk that has been already created. The same applies to the storage or the origin, which is often combined with the encoder for obvious reasons. Most market standard storage solutions are, however, not sufficient for latency workflows due to inconsistent and slow read after write and read after update speeds. We need to allow the origin to serve the data before the file is fully uploaded. And now we move to the caching infrastructure of things. Following the very same principle, we are moving the HTTP chunks across the entire caching infrastructure, and regardless of how many caching layers we have. The principle is always the same. As soon as the smallest playable unit is created, it is passed down to another level. The real strength, however, comes from any combined request coalescing with data prefetch. Data prefetch is obviously not a new idea in any way, but its deployment for live streaming is much more sophisticated than one would think, as the prefetch can be initiated even before the content or the segment is fully created. Again, let's come back to the smaller HTTP chunks, making their way across the individual layers. These small chunks can also carry information about the next segment that has yet to be created. Thanks to this information, the CDN can start proactively prefetch and fetch the next segment in line and initiate its caching even before the end user requests it. As a simple example, 4 to 5 seconds of 4.5 seconds of 5 video segments are created and served. And the last 5 HTTP chunks of the segment carry information about the next segment. The CDN can immediately ask the origin for the following segment in this way. And if the segment is not even partially created, the origin does not answer with 404, but instead keeps the request open until the first HTTP chunk is created and then passes it forwards. By the time a piece of video is requested by the end of user, we should ideally have it created and cached as close as to the edge layer. Yeah, and so yeah, now we move to the multiple layers of the caching infrastructure. The very first caching layer should ideally sit very and really close to the origin layer, whether in the same CD or even in the same data center. I mean, PNIs between us CDN providers and clients, client origins are common thing these days, and we really like to push forward this idea. And the really same approach kind of work on the edge level. The lesser the distance between the edge servers and the end users, the better. And great edge great edge connection or deploying local caches, placing infrastructure right within the network of ISPs really helps. It allows to CDN to cache the content at the final destination, closer and the closest to the edge user. Then we move to the overall network infrastructure. And of course, all these caching layers need to be connected by a robot and run the network. Once the content hits the CDN, and the CDN can distribute the data across its networks to the caching layers and right to the edges. Using our own private network gives the CDN much more control over the transfer itself and the stability. The idea here is really to reduce the dependence on the public internet throughout the majority of the data transfer. So rather than relying on the public internet infrastructure, you really want to ensure that you move and transfer the data to your own stack where you can control the quality at each of the steps. With each production deployment and use case adaptation, CDNs are getting smarter in content handling. And use case adaptations such as these force CDNs vendors as us to bring more power to the edge. The edge is no longer a simple caching proxy as it was before, but rather quite a complex multi-layered service that can be fine-tuned for specific client needs. For some use cases, it makes perfect sense to keep the entire workflow at the edge layer, so the content stays local if the source and viewerships are in the same geographic area. This scenario saves unnecessary network round trips if the use case allows it. However, we've been also looking into further optimization than what I described before, namely into per title encoding. The idea is to serve clients with less than ideal network conditions, and whether it be a mobile network or slow network connection overall. It's a feature that is widely used in VOD scenarios now, but it's only making its way into live streaming. Truly efficient adaptive video streaming really relies on constructing efficient bitrate ladders, which we can see here. And efficient bitrate ladders always deliver the best possible visual quality to the viewers under bandwidth constraint. So instead of usual static predefined set of qualities that you may use usually or before, and bitrates with it, we analyze the complexity of stream content live, and in order to predict the ideal bitrate ladder and quality profiles. We can see that each resolution has a bitrate region in which it outperforms other resolutions on the right side. And if we collect all these regions from all these resolutions available, they collectively form a boundary that's called a convex hull. In an economic sense, the convex hull is where the encoding point achieves Pareto efficiency. Put simply, we are looking to offer the best image quality over lower bandwidth, and optimize it for each bit of content that you may have individually. It's a win-win situation. It's probably strange to hear that the CDN guy to say that lower bandwidth is a win-win situation, right? But from a technical perspective, the less data we need to transfer, the better. Yeah, and in a world where CDNs are becoming increasingly commodities, scenarios such as live streaming are pushing us CDNs to bring extra value, and that can lead to long-term and strategic partnership with clients. So thank you for listening to the presentation. I'm happy to answer any questions that are in the Q&A, and yeah, so we can move to that.
Okay, great. And thanks, Yuri. That was fascinating stuff. And we actually don't have any questions in the Q&A right now, and we're right at the 2:40 mark. So
oh yeah, we made it just in time.
Sebastian's of his time. But if you do have questions for Yuri, go ahead and just put them in the Q&A, and he'll just answer you there directly in the Q&A. And we'll just we'll move on to Sebastian from Matrix. Thanks, Yuri.
Yeah, thank you all.
Hey, thank you, Steve. Let me share my screen here with you guys. Can you see this?
Yeah, it looks good.
Awesome. Thank you. All right. So let me take a moment real quick to introduce who Verimatrix is for those of you who don't know. We've been around for quite some time, over 25 years. We've are focused on content protection, on VOD, obviously, large catalogs of that, broadcast, linear channels, and obviously also live content. That's where a lot of the value that our customers have is gathered up in. We have about 800 plus customers globally. I always say we're over 300 security and content protection enthusiasts here at Verimatrix. One of the things I will point out that we're super proud of is winning the Innovations Award for our use of machine learning and artificial intelligence when it comes to cybersecurity at NAB this year. That was a great achievement. So toot my own horn there a little bit. So who are we? At the core, we believe that artists, sports leagues, content creators, content distributors, anybody who invests in getting content and getting experience to consumers should get paid at the end of the day, right? We should have secure revenue channels. We invest a lot of money in the content, the R&D to build our applications, to maintain our infrastructure. That's a lot of investment. And in a sense, we're competing against piracy. So to that end, we are focused on building solutions that protect these types of connected experiences. And we secure, detect, and defend actually against cybersecurity attacks beyond just video, but specifically here we're focusing on video, that could be of threat to our customers' revenue. We work with major studios, major content creators, sports leagues to define what requirements should be in place to protect the content. And then we actually develop with some of the world's largest brands. And you can see some brands here that are not video related, but for example, banking, finance, healthcare, automotive, where we protect other digital assets. But the majority of our business today is focused on content protection, video protection. So let's talk a little bit about protecting this high value live content, right? So we just had World Cup 7 months ago. That was one of the major events, global major events, where there is a lot of value actually tied up in that content, in distribution. Takes an entire village to go secure that delivery end to end. But before we go in there, I want to thank anybody who is a vegetarian on the webinar today for being patient with me. Because today's pirates want the whole cow. So this is sort of the analogy here. They're not only after the content, they're not only after pirating the video, but they're also after the, for example, subscriber data, payment information, billing data. Oftentimes what we see today in piracy is that the pirates are actually going to attack a service and redistribute the content directly off the service's network, for example. So we require additional security methodologies there to protect that, to protect against that pirate use case. We also see, for example, ad hijacking. I think there was a question earlier about server-side ad insertion. If you have an unsecured endpoint or an unsecured experience on an app or on a web app, that can potentially be swapped out and the ad inventory replaced with pirate inventory that then can get monetized. So how do we protect that? So some of the capabilities that we recommend here, and you can kind of look at this chart as what we do before something actually gets compromised, an app or a video or a player or a CDN. What can we do before and what do we do after? So before, at the very basic, we have our DRM implemented that protects the content. We have now our application, our web app, our Android, our iOS app, our app on a set-top box. We have that protected with code obfuscation, shielding the entire application. While we're doing that, we're also injecting, now in the bottom right corner here, we're also injecting some monitoring to actually see on the device and detect when a hacker is attacking the application or is attacking certain parts of the application. And then we have countermeasures in place. So when we find that, we can take action. So for example, if we see that, there's a hooking framework attached to the application or another attack that we're seeing, we can actually go and say, okay, you know what, this device or this subscriber is up to no good. Let's degrade the video quality, or let's potentially go as far as crashing the application on that device or shutting that endpoint down and preventing it from leaking content. Now, based on all of these things and the data we collect, we also calculate what we call a piracy risk score. So this is a risk score that allows us to assign for each device a score that tells us, how risky is this device, or how likely is it that this device is up to no good, is trying to steal the content, trying to hack the app, trying to get into the ad integration, trying to get the billing data out of your subscriber base. So those are the kind of things that go into this piracy risk score. And based on that risk score, our customers can then take action, decide if they want to have a degraded user experience, or take certain actions to manage that customer. So this is a little bit of an analogy, right? So the approach that we're taking is really a layered approach. So at the very core, you do have your content. That content is encrypted. That content is using DRM. We've, in addition to DRM, as an industry, we've layered on elaborate authentication methods, tokenization of requests that are being made, for example, to our services or to CDNs. And pirates are always trying to find or trying to get ways around, experimenting how they can get into the service, and eventually compromising the service, getting access to the service, and then pirating the content or stealing data. So really, this kind of goes to our prevent, detect, respond, predict methodology. It's almost like preventing, obfuscating the code, protecting the actual application, similar to building a fence around your building, making it harder for somebody to go enter the building. Detecting, much like having video security installed in sort of the physical world, observing any type of attack that may come on. And then, the security guard sees something, finds a hole in the fence, gets sent out to that hole in the fence, sees what's going on, responds to that, takes action. But wouldn't it be also nice if we were able to predict where in the fence this next hole is actually going to appear, and send the security guard preemptively to that and actually prevent an attack happening? So this is the approach that we're taking beyond DRM to really secure, especially in the live world, in the live streaming world, this high value content that's being delivered to consumers. So just to summarize, what we offer is beyond DRM. So DRM alone is great, but DRM alone is not enough. Our portfolio provides a holistic, full range set of solutions around cybersecurity. We're using that not only, like I said, in video, but also in banking, healthcare, and automotive. And those three products that you see here on the side, multi-DRM, counter-spy, and watermarking, are the combined solution portfolio that we have there. So let's see if we have any questions. Thank you for that. I don't know, Steve, if you see any questions.
So we don't have any questions from the audience yet, but I actually have some questions. But please just get your questions in, and we will prioritize your questions when we see them. But yeah, so I just want to be clear. It's almost like you're saying you can't deal with piracy with DRM. Like, it's almost worthless. I mean, that seems pretty extreme.
Yeah, I think a lot of people ask me, like, oh my gosh, are you saying like we shouldn't encrypt our content and not use DRM? And actually, I'm not saying that at all. I think DRM is good. DRM is there. It's at the core of a service specifically designed to, manage license policies, think about what types of quality of content you want to send to what types of devices. And there's already some understanding of risk, of understanding how risky a device is built into DRM, but it is relatively old technology, and it's not as flexible as some of the more modern approaches that we expect, specifically for content protection, as we're moving everything to the cloud, right, from a managed network. So we need more. We need more than DRM. Yeah, for sure.
I think it's kind of outdated. Is that what you're?
Yeah, for the types of use cases, or I shouldn't say use cases, for the types of attacks that pirates are going after today, DRM is not enough alone.
Well, I know some people would disagree with you on that, but it's a bold statement. We
And-
like statements.
And this is coming from us, right? I mean, Verimatrix, we've been in the industry for quite some time. We pride ourselves on having our own DRM. We implement many other DRMs for our customers. And really by way of seeing and kind of hearing from our customers firsthand these problems that they're experiencing even after they have encrypted content and they have protected the content with DRM. That's really what got us to kind of look at what we're doing in this non-video world. How are we protecting, for example, banking mobile applications, and how can we use these technologies to add more value to premium content, to video content? And I think live and streaming is obviously some of the most high value content that's out there. And it becomes important to do that. The other thing I heard a lot of people talk about latency. That's another thing, right? If you look at the whole sort of shutting down a pirate, the actions that you have to go through to catch a pirate, shut the pirate down, it's very cumbersome. And it's, if you think about 2 hour, 3 hour sports event, you have a very limited time. You need to do this fast to regain your value. Or to capture the most value out of it. And for that, some of these machine learning or AI technologies that we provide are actually much more suited to take preventative action, really, if you will, than solely relying on, trying to search the web, find a watermark, resolve the watermark. You do need to do those things to, obviously have proof of ownership of the content, be able to go and see where this content is being leaked. But really to protect the value, again, I think it comes down to do more and take a more generic cybersecurity stance at these problems.
Okay, makes sense. So we actually have a great question from attendee Enoch asks. So the pirates are still getting the content. Do you think this can substantially impact levels of pirating proprietary content?
I love the way that question is phrased, because you never fully can get rid of piracy, but yes, I believe it can substantially impact that. And one of the types of attacks that we're seeing a lot more of is token theft and license resharing and DRM license resharing and so on. And what a great business model for the pirate, right? To be able to deliver the content directly of the distributor's network and potentially actually charge their subscribers a subscription fee on the other end. And so that's like one of these things where it's not just the content owner requirement to go encrypt the content, but you now have real costs associated to the piracy. And so against those types of attacks, this can prevent a lot of those attacks, keep that incremental operations overhead and that cost in your pocket, and have a substantial impact on resharing and pirating content.
Right. And so we got another question from Sarah. So you mentioned AI tools, and so she asks, could you please give examples of AI tools that you're using?
Yeah, so we're in the cloud. We're using several tools, different ones on AWS, and really what we find is, or I should say machine learning, what we find is we have a pretty extensive data team, and we're constantly, and this is why we sort of need to still verify piracy by way of watermarking, finding the leaked content out there to create these training data sets to train our models. So we're spending a lot of time on that in the cloud, primarily across AWS, Google Cloud, and Azure.
Okay. And Beth asks, do the piracy culprits leave any footprints that you can follow? And can AI address that?
Yes, so absolutely. So, and this goes back to on the slide where I was talking about injecting our monitoring agent that monitors for attacks and sees sort of the environment in which the application is running. yes, there is some very clear behavioral markers that we see, for example, leading up to an event or during an event that have very, very high correlation to that device ending up leaking content or redistributing that content. Oftentimes it starts with wiping the app, reinstalling the app new, and you can kind of see, we had one case in the past where we've seen that happen, almost like on a timer. Every time it was a professional soccer league, almost on a timer before every game, the Pirates would go on a particular device through the same scenario, and then begin leaking from that device. And the way that you prove that that is actually the source of it is still you mark that content in a forensic, very, very hard to remove the mark way to tie that back. So yes, there's always ways to follow those leads.
Yeah, it's amazing that you can identify and track their MO even when it's pretty sophisticated.
Yeah, and I mean, thanks to machine learning and AI, those things are speeding up. It really helps us to cut down our reaction time, and do something about that problem faster. And especially, going back to the topic at hand here, delivering live content. We focus a lot on latency on the way to play it out, and we're also focusing a lot on taking action very fast in case there are compromises and attacks that we see.
That makes sense. So an interesting comment just here from Jorge, which kind of correlates to your cow analogy, actually. So Jorge says, I would add that it's the security mindset, which is a layering approach. So one layer of the Swiss cheese, it's the cow thing, does not cover all the holes. You need multiple layers.
Exactly. No, exactly. So, we throw a lot of analogies around. The DRM is like the lock on your front door, but somebody could unhinge the door and take it out. Or, you have the best lock on the front door, but every time you leave the house, you leave the bedroom window open. Exactly. So that's really it, because somebody wants to break into your house, they're not just going to see, oh, the front door, is it open? No, it's locked. Okay, I leave. No, they're going to go around. They're going to try to find different way. They're going to experiment, use different technologies, use different attack vectors and methodologies to try to get in. You have to have visibility into that.
Right. And we have time for just one more question from Joanne. She asks, I understand your intent is to identify and remove the risk, but does your model adjust for law enforcement intervention?
That's a good question. I'm not sure I totally understand that, but you mean law enforcement intervention after the fact, once we actually gather the evidence to do something about that? I mean, in a live streaming scenario, if you think about that, yes, we can contribute our findings to an investigation. The likelihood that you're going to do something about it during the live event is pretty low in terms of law enforcement, etc.
Fair enough. So yeah, that was what she meant.
Yeah. Okay.
So yeah, so that's actually all we have time for today. But this has been great. I appreciate all the presentations today. Thank you, Uri. Thank you, Ahmet. Thank you, Sebastian. And if you would like to review the event or send a colleague to view it, it will be archived for 90 days, and you'll receive a follow-up email just after the event, letting you know that the archive is ready, and you'll get a link to it. And as we mentioned at the beginning, thanks for coming back in, Ahmet. As we mentioned at the beginning, just for attending today's event, you're entered to drawing for a $100 Amazon gift card. And Tyler tells me the winner is John Angst. So congratulations, John. You'll be getting an email also telling you how to collect your prize. Thanks again. Thanks to all our presenters. And thank you for joining us today. We hope to see you again.
Thank you, Steve, and everybody on the call.
Thank you guys. Have a great day.
Thank you.